Okay, students, counting principle. In this chapter, we have two types of counting principles. One is called sum rule, and another is called product rule. First of all, I want to explain about product rule. After that, sum rule. Okay, students, listen. This is the rule to count the things. Okay, listen all of you. For example, A, B, C are three towns. A person want to travel from A to C via B. From A to B, we have two ways. Say X1 way, X2 way. B to C, you have three ways to travel. We assume that one is airway and roadway and seaway, like that. Y1 and Y2, Y3. Now the question is, how many different ways a person can travel from A to C? Practically you can say that I can write the ways X1, Y1 means airway. X1, Y2 air and roadway. X1, Y3. So what I can say, road and seaway. X2, Y1 sea and airway. X2 and Y2 sea and roadway. X3 and Y3 sea and seaway. Means a person want travel from A to C via B, he can travel in 6 different ways. 1, 2, 3, 4, 5, 6. Okay, students, here important thing is, by using product rule, how can you say correct direct answer? From A to B, you have two ways. B to C have three ways. You want to travel from A to C via B. Via B means after traveling from one place to another place only, you can travel from another place to another place. Means traveling from A to B or traveling from B to C is depend upon traveling from A to B only. One operation is depend upon another operation. In this case, the number of ways he can travel from A to C is nothing but 2 into 3. 2 into 3, that is equal to 6. Students, listen. A to B, we have 3 ways to travel. B to C, we have 4 ways to travel. Write all. Write all. We get 12 ways. 12 ordered pairs we will get. Write all. 12 ordered pairs. This is X1. This is X2. This is X3. Say this is Y1, Y2, Y3, Y4. Write all. We get 12 ordered pairs. Just like A cross B only. No? 12 ordered pairs. Means what happened? A person want travel from A to C via B. He can travel in 12 different ways. What is the meaning of this? First of all, he should travel from A to B. Then after B to C. While traveling A to B, he have 3 ways. B to C 4 ways. After completion of this operation only, he can start this. After traveling from A to B only, he can start B to C. Means one operation. Operation means traveling from B to C. One operation is depend upon another operation. That's why one thing is depend upon another. In this ways, you want to use product rule. 3 into 4. 12 ways you can travel from A to B. Listen, students. So from A to B, there are 5 ways to travel. From B to C, you have 2 ways to travel. A person want to travel from A to C. How many different ways he can travel? Directly you can say that 5 into 2, 10 ways. No need to write anything. How can you say? Means I can say product rule. What product rule says that one operation can perform in M ways. After completion of that second operation can perform in N ways. One operation depend upon another. So these two operations successively you can perform in M into N ways. This is the definition of product rule. Okay. Not only 2 nana. For example, A, B, C, D are there. A to B have 2 ways. B to C have 3 ways. C to D have 4 ways. A person want travel from A to D via B and C. How many different ways can travel? Means you can see that 2 into 3 into 4 ways he can travel. Okay. So what is the meaning of product rule? You can perform a first operation in N ways. Second operation in M ways. Third operation in Q ways. One operation depend upon another. So three operations successively he can perform N into M into Q ways. Okay, this is called product rule. So by using product rule you can solve so many problems. Okay. Students, listen. One of the problem. There are 2 towns A and B. there are 10 bus services are running from A to B, 10 bus services are running from A to B, say bus 1 and bus 2, buses are numbered as B1, B2, so on B10. A person want travel from A to B and he want return in different bus. Okay students, first of all, among these 10 buses, he can use any one of the bus to travel from A to B. For example, he used bus number 1. So while in return journey, then from B to A, he can't use bus 1. B1 he can't use. He can't use B1 means he can use B2 or B3 or B4 or so on B10. If you use B2 initially, he can't use B2 while return journey from B to A. So he can use B1 or B3 so on B10. How many different ways he can travel? That is the question. In travel means he should travel from A to B, then after he should return. How many different ways he can travel? I will write, observe all of you. I will write. First of all, from A to B, he used bus 1. Nana. So B to C, what happened? B to C, he can't use bus 1. No? He can use B to B3, B to B4, B to B5, B to B6, like that. B to B10 or B3, B2. Sorry, B3, B2 complete, all are counted. No? B3, B4, B3, B5, like that. You need to count. But we can't write all directly. No? So by using product rule, you can say the answer. First, he can have 10 chances, 10 bus chance. He want travel from A to B, he have 10 chances. He can use B1 or B2 or B so on 10. 10 ways he can travel from A to B. Okay. So now you want return B to A. You have only 9 chances. You can't use any one of the bus that is travelled from A to B. So the second while return journey, you have only 9 chances. 9 chances. Second operation you can perform into 9 ways. These two successfully you can perform into 10 into 9, 90 ways. Means that he can travel 90 different ways from A to B and he will return B to A. Okay. So this is the one of the application of product rule. So I will explain one more example how to use product rule. By using 2, 3, 4, 5, how many 2-digit numbers you can write? 2-digit numbers, no digit is repeated. No digit is repeated. How many 2-digit numbers you can write? So just first of all I will write practically 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. Next 3, 2, 4, 2, 5, 2, 4, 3, 5, 3, 5, 4. What happened and how many? 1, 2, 3, 4, 5, 6 plus 6. 12 2-digit numbers you can write by using this 4 digit. No digit is repeated. But how to say our answer by using product rule? Why I am saying, for example, 10 digits are given, you want to make a 3-digit number, so it is difficult to write all. So by using product rule, you can say the answer. Observe all of you. Okay, sorry, 2-digit number only now. Okay, 2-digit number you want. So just I want to fill these 4 digits in these 2 blanks. I can write here 2, here 3, or here 4, here 5, like that. Just I want to fill those 2 blanks by using these 4 letters, 4 digits. First box I can fill in 4 ways. I can use 2, or I can use 3, or I can use 4, or I can use 5. 4 ways I can fill first blank. Okay students, that is unit place. So this place I can fill into 3 ways because any one of them is already used up. No, here I either 2 or 3 or 4 or 5 used up. So what is my condition? No digit should be repeated. That's why to fill this blank we have only 3 letters, 3 digits. So second box I can fill into 3 ways. First box in 4 ways, second box in 3 ways. These 2 consecutively I can fill into 3 into 4 ways by product rule, that is 12 ways. So that is the answer for the problem. Okay. If repetition allows means 22, 33, 44, 55 also allowed. 12 plus this 4, 16 2-digit numbers you can write. By using product rule, how can you say answer? That is interesting thing. Okay, first box I can fill into 4 ways. Second box also 4 ways only. Any one of them again you can use. No, for example, here used 5 is used already. I can use 5 also here. What is the problem? 55. That's why again second box also can fill into 4 ways. By product rule I can say that 4 into 4 that equals 16 ways I can fill the 4 letters in 2 blanks. Means I can say that there exist 16 2-digit numbers. So I don't want explain some rule now. I don't want to explain now because that is not important for us now. That is another chapter, that is permutation combination chapter actually. So on that time I will explain both the rules and I will explain through examples. But I want only product rule here. So this is the product rule. Why I am using product rule here? What is the use of product rule in functions concept? That is important. Listen all of you. Listen all of you. There are n different objects, n different objects, n different digits, n different digits. Okay, actually in mathematics we have only 10 different digits. No, objects I can say 10 n different objects are there. I want fill into 3 blanks. I want fill all these into 3 blanks. Repetition won't allow. First blank I can fill n ways. Any one of them I can use, no, n ways. Second blank I can fill into n minus 1 ways because already any one of them should be used, no, here. So 2 used, no, remaining are n minus 2 are there. To fill third blank I have n minus 2 ways. How many ways you can fill these n different objects into 3 blanks means I can say n into n minus 1 into n minus 2 ways I can fill. So this is answer, n into n minus 1 to n minus 2. One more important thing, Nana, factorial notation important, factorial. What is the meaning of factorial? 5 factorial means the product of first 5 consecutive natural numbers. 3 factorial means the product of 3 consecutive natural numbers. Okay, 6 factorial means the product of first 6 natural numbers, the continued product of first 6 natural numbers. 1 into 2 into 3 into 4 into 5 into 6. So 6 factorial also sometimes written as, this is nothing but 5 factorial into 6. Means 6 factorial can be written as 6 into 5 factorial. 6 into this 5 factorial sometimes written as 5 into 4 factorial. Understood? So this interesting thing is, listen all of you. Yeah. Now I explained what is the meaning of factor. N factorial, the product of first n natural numbers. 3 factorial, 1 into 2 into 3. 5 factorial, 1 into 2 into 3 into 4 into 1 into 2 into 3 into 4 into 5, or 5 into 4 factorial also can write. But mathematical convenience, 0 factorial is treated as 1. Okay. Yeah, listen students. Now n different objects are given, n different objects, all are different. We want fill into r blanks here, r 1 2 3 like that. This is first blank, second blank, third blank, so on, rth blank. We want fill these n elements r blanks. First blank I can fill n ways, repetition not allows. Second blank I can fill n minus 1 ways. Third blank I can fill n minus 2 ways, so on. Rth blank, see, first blank means n minus 0 you are getting. Second I will write here, first blank n ways. Second blank n minus 1 way. Third blank n minus 2 way. Fourth blank n minus 3 way. I can write this as n minus 0. Or n minus 2 minus 1 I can write. N minus of 3 minus 1 I can write. N minus of 4 minus 1 I can write. Rth blank you can fill n minus of r minus ways. That is n minus r plus 1 ways. So how many ways you can fill directly by using product rule? All these n articles or n objects in these r blanks. How many ways I can fill means n into n minus 1 into n minus 2 into n minus 1 n minus r plus 1 ways. I will write that here. Okay, filling n different objects in R blanks which are arranged in a row important. How many ways means n into n minus 1 into n minus 2 into so on n minus r plus 1 ways. First blank n, second blank n minus 1, third blank n minus 2, so on. Product rule you can say that n into n minus 1, n minus 1. So in mathematics, this is symbolical as NPR. NPR mathematically. So detailed discussion in next chapter, Nana, that is permutation combination. Just this formula I want to solve some problems in set theory. That's why I introduced it. Okay, you should accept this. NPR means n into n minus 1 into n minus so on n minus r plus 1. For example, 5p 2 given. So 5 into 5 minus 1 into up to what? Up to what important? You need to use this. 5 minus r means what here? 2 plus 1. So 6 minus 2. What is 6 minus 4? Up to 4 only. Up to 4 means what? 5 into 5 minus 1 completed. So that is 5 into 4, that is equal to 20. For example, you want a 10p3 you want. 10p3 you want. How to write 10 into 10 minus 1 into how many ways you want to reduce? That is depend upon last. 10 minus 3 plus 1. That is 11 minus 3. 11 minus 3 means what, Nana? 8. Up to 8. Here 10, here 9. After next term only. 10 minus 2 completed. So that is the value of 10p3. Okay. So another way what I can say, 5p2 means 5 into 5 minus 1. 2 times. So two brackets. 5p3 3 brackets. First 10. After 10 minus 10 minus. Stop. For example, you want 6p4 you want. 4 brackets. First bracket 6, 5, 4, 3. That's all. What is the value? That is 6p4. What is the meaning of this, Nana? What is the meaning of this? 6 different objects are given. You want to fill into 4 blanks, which are arranged in a row. How many ways you can fill means I can say that 6 into 5 into 4 into 3 ways. Okay. So this is called product rule. NPR means n into n minus 1 into n minus so on n minus r plus 1. The meaning of this notation is, meaning of this notation is n different objects are given. We want to fill these n different objects in r blanks which are arranged in a row. How many different ways you can fill means I can say that NPR ways you can fill. NPR is nothing but this. Okay. Actual formula for NPR is given as n factorial by n minus r factorial. You can remember this. Okay, how you got everything I will explain next chapter, Nana. Just here you want the meaning of that symbol. That is enough. NPR means n factorial by n minus r factorial. So, or you can remember this. Easily you can remember this. No, just I explain. No? 10p3 how to remember. 10 should be reduced 3 times. 10 into 9 into 8. That's all. Yeah, counting principles are two. One is thumb rule and is product rule. I explained product rule. I won't explain sum rule now. That I will explain next chapter. Just product rule, we have the formula NPR means what? Meaning. This is a natural number. This is also whole number. Okay, R may be 0, but n is not equal to 0. Okay, NPR means n into n minus 1 into so on n minus r plus 1. Should remember, or sometimes this can be remembered as n factorial by n minus r factorial. That is not big thing. Just no need to use any formula. For example, 10p4 you want, just 10 reduce 4 times, Nana. 10 into 9 into 8 into 7 completed. What we will get? That is 10p4. Okay. Yeah, actual special type of function. Yeah, special type of function important, Nana. This is very, very important. First one is 1 function. 1 function. Or injective mapping. Injective mapping. or sometimes injection, whatever it may be. One function, one function, important. Listen all of you. So first of all, I want to explain meaning of the function. Through examples I will explain. Students listen. 1 2 3 a b c. This is function only. F1 is function from a to b. F2 not function, because all the elements are used up, but one used 2 times. F2 is not a function. F3 also not a function, because all elements are not used up. Yeah, F4 is a function. F4, listen student, F4 is a function and F1 also function. But F4 is called a special type of function called 1 function. F4 is a 1 function. F4 is 1 function. Why it is called 1 function? 1 function definition saying that different elements should have different images. 1 and 2 are different, their images also different. But here 1 and 2 are different, but their image is same, no? 1 and 2 are paired with A. 1 and 2 are different, but their images are same. Such function is not called 1 Different elements are paired with different elements in the codomain. Such function is called 1 function. 1 and 2 different, their images are different. 2 and 3 different, their images are different. 1 and 3 different, their images are different. Such function is called 1 function or injective mapping. Understood? So F is a function from A to B, so that different elements of A are paired with different elements of B. Listen student, this is set A, Nana. This is set to B. F is given function from A to B, function from A to B, function from A to B. So when you can say that is 1 different elements are paired with different elements of codomain. Different elements of domain are paired with different elements of codomain. Some elements will left in codomain, that is not a big problem. But what happened here, the elements are different, their images should be different. Observe all of you, important. AB. X1 and X2 are the elements in domain. For example, X1 is the element in domain, automatically their images should be, no? Say this f of X1 by notation. Image of X2 is f of X2. If these two are different, these two should be different. I will write that. X1 not equal to X2, it become a 1 function. What should happen, Anna? F of X1 should not be equal to f of X2. Means the elements are different, their images should be different. One thing. If X1 equal to X2, if these two coincide, these two should coincide. Otherwise, it will not become a function. For example, these two are coincide, these two are not coincide. That is not a function. What is the meaning of this? If these two are coincide, these two should coincide. That's the way I can write. X1 equal to X2. If X1 equal to X2, then f of X1 should equal to f of X2. Then only given function is become 1 function. Okay, then only you can say that given function 1 function. This is the condition for 1 function. Condition. What is the condition? What is the definition? Different elements of domain should be paired with different elements in codomain. Then such function is called 1 function. So how to write definition? So I will write like this: if X1 comma X2 belongs to domain of F, then there exists f of X1 comma f of X2 belongs to codomain. Why there exist? Because function, no, two elements are there in the domain, automatically their images should be in codomain. Let there be f of X1 and f of X2 belongs to codomain. So if X1 not equal to X2, then what should happen? F of X1 should not be equal to f of X. Then only f is 1 function. This is one first condition. Or second condition, if f of X1 equal to X1 equal to X2, then automatically its image should be equal. That is f of X1 equal to f of X. Then only given function should be a 1 function. Okay. So this is the definition. Listen, 1 function or injective mapping, and this is later, na? Many to one, later that one. First of all, 1 function. A function f map a to b is said to be 1 function or injective mapping if different elements of a have different images in b. Thus, x1 comma x2 belongs to a, f of x comma f belongs to b, f of x1 equal to f of x2. W implies x1 equal to x2. What is the meaning of W implies means? If x1 is equal to x2, then f of x1 should be equal to f of x2. Or f of x1 equal to f of x2, then x1 should be equal to x2. So here f of x1 not equal to f of x2, W implies f of x1 not equal to f of x2. So this is the definition of 1 function. If a function is not 1, it is said to be many to one. Note, that is important. If a function is not 1, it is said to be many to one function. Okay, but how to find number of 1 function? That is very, very important. Observe all of you. 1, 2, 3 given. Here A, B, C, D given. Sir, no, I don't want to take less elements. I want to take. For example, 1 minute. Yeah. Here 1, 2 is taken. Here A, B, C are taken. Now I want to find number of 1 function that can be written from A to B. 1 function, I am saying 1 function. I will write here, observe all of you. 1 to ABC, 1 to ABC, 1 to ABC, 1 to ABC, 1 to ABC. Okay. Yeah, listen. 1, 2, 3, 4, 5, 1 to ABC. Yeah. This is 1 function, observe now. This is another 1 function. This is another 1 function. 1b, 2a, 2c, this another 1 function. What next? 2a and 1c, another 1 function. 1, 2, 3, 4, 5. One more 1 exists. I want to write. What is that? 2c, 2c, not okay. 2c, 1b, 2c, 1b. Where is that? 2c, 1b, 1a, 2c, 1a, 2c, 1a completed. 2b, 1c, 2b, 1c, not there. That's what I will write. 2b, 1c. Cross check nana. 2b, 1c. I think not there. 2b, 1c, not there. So this is another one. So 1, 2, 3, 4, 5, 6. There exist 6 1 functions from set A to set B. But how to derive a formula for number of 1 functions from A to B? Listen all of you. A having 2 elements, B having 3 elements. Okay, now we want to find the formula how to find the number of 1 functions. Listen students. 1 can pair with any one of ABC. 1 have 3 chances. 1 can pair with either A, or 1 can pair with B, or 1 can pair with C. 1 have 3 chances. For example, 1 is paired with B, for example. Now 2 have how many chances? That is important. I can't pair 2 with B, no? Then it is not become 1. So I can pair 2 with A or C. 2 have 2 chances. 2 have 2 chances. 1 have 3 chances. 2 have 2 chances. From product rule, the total number of ways you can pair 1, 2 with ABC, so that it is 1 means I can say 3 into 2, 6. 6 different 1 functions exist from A to B. Practically also I got the same thing. Okay. Now I want to generalize the students. Listen, 1, 2, 3 given here. Here A, B, C, D given. Students listen, Nana. 1 have 4 chances. 2 have 3 chances, because any one of them, 1 can be paired with either A or B or C or D. No? 2 have 3 chances. 3 have 2 chances. By product rule I can say that 4 into 3 into 2. 4 into 3 into 2. 1 functions exist from set A to set B. Yeah, 4 into 3 into 2 nothing but 4p3 only. No? Just I explained 4p3, 4 should be reduced 3 times. 4 into 3 into 2 and 4p2 only. Here 3 into 2 and 3p2 only. So 3p2 1 functions exist from A to B. Here 4pt 1 function exists from A to B. 4 stand for number of elements in codomain. 3 stand for number of elements in domain. Students listen. A have X element, B have Y elements. how many 1 1 functions exist from A to B? I can say ypx according to product rule. Okay, so actually what yp they stand, that is actual permutations. So we will discuss later about that. Just ypx means y into y minus 1 into y minus 2 so on y minus x plus 1 ways. So that is the meaning. Okay. Students listen. Nana. Yeah. A having 1, 2, 3, 4, 6. Here A, B, C, D, E, F. 1, 2, 3, 4, 5 elements here. 1, 2, 3, 4, 5, 6 elements. How many 1 1 functions from exist from A to B? Means I can say that 6p5. That is 6 into 5 into 4 into 3 into 2. 1, 2, 3, 4, 5. Okay. So what we will get? Those many 1 1 functions exist from A to B. Don't think that B to A to B. This is one important thing. Next thing is, for example, here only 4 elements are given. Here also only 4 elements are given. 3 given. Here 3 given. How many means? Here 3p3. 3p3 means 3 into 2 into 1. That is not 3 factorial. That is not 3 factorial. Means npn is nothing but n factorial. 4p4 means 4 factorial only. We can write 4 into 3 into 2 into 1. So npn means n factorial. 4 means 4 factorial. So important thing is, if number of elements of first set equal number of elements second set, how many 1 1 functions exist means I can say 3 factorial. This set having n elements, how many 1 1 functions exist from A to B means I can say the n factorial. Okay. This is one thing. Second important thing, students, listen all of you. 1, 2, 3, A, B, C, D. 1, 2, 3, 4, A, B. Here n of A is lesser than n of B in first situation. Second situation, n of A greater than n of B. Observe. Here how many 1 1 functions exist from A to B means I can say that 1, 2, 3, 4, 4p3 or 4 into 3 into 2. But here in this case we want to find how many 1 1 functions exist from A to B. So 1 can pair with any two chances are there for 1. 2 only 1 chance. What about 3? No chance. No chance for 3. No chance for 4. Means 1 1 function won't exist. First functions exist but the 1 1 function won't exist. What is the meaning of that? Your n of A should be less than n of B, then only 1 1 functions exist. Means the condition is n of A should be lesser than or equal to n of B, then only 1 1 functions exist from set A to set B. If n of A greater than n of B, you can say that 0 1 1 functions exist from A to B. So here clearly given n of A is equal to R, n of B equal to n. Then the condition to define an injective from A to B is n is lesser than or equal to R, just like what I explained. Okay, and the number of such injective mappings are NPR, just now explained. So n elements in codomain, R elements in domain. NPR 1 1 functions exist from A to B. So if R is greater than n means n of A greater than n of B, then number of injective mappings are 0. No injective mapping exists from A to B. Okay, students, important. If a function is not injective, just simply you can call it as many to one. That is important. If a function is not injective, that is simply said to be many to one function. Okay. Yeah, example. F map R to R defined by f of x equal to x square plus 1, then show that f is not 1 1. Yeah, student, this is an important example. This type of problem is important. If rules are given, how to check they are 1 1 functions or not, that is important. So what is the meaning of this nana here? This is R. Elements of domain are paired with elements of codomain under this rule. Now you want check whether that rule gives 1 1 or not. For example, 1 is taken. 1 should be paired with 2 only, no? 1 square plus 1. 2 is taken, 2 square plus 1, it's paired with 5. If minus 1 is taken, what happened? What happened? Minus 1 also paired with 1, 2 only. Observe minus 1 square, 1 plus 1, 2. What is the meaning of this? 1 and minus 1 are different, their image is same. Means that given rule is not 1, 1. Okay, square, 4s are given, should take care, Nana. So I will write. Let x equal to 1. Then f of 1 equal to 2. If x equal to minus 1, then f of minus 1 equal to 2. What happened? 1 comma minus 1 are different. But their images are same. Therefore, f is not 1, 1. Not 1 means what? It may be any another function, or simply I can say that many to one function. Okay, very, very, very important definition. Okay, now I want to write another example too. F maps n to R defined by f of x is equal x square plus 1. Then verify that f is 1, 1 or not. Verification. Then verify whether f is 1, 1 or not. Just verification. So again, some students will make mistakes, Nana. Square is the no, sir, so it is not 1, 1. Not correct. Square or whatever it may be, depend upon domain, natural numbers only, no. Yeah. Domain is natural number, range is, codomain is all real number. Here natural numbers only, 1, 2, 3, so on. Natural numbers only, no. 1 paired with 2, 2 paired with 5, 3 paired with 9, 10. What is the meaning of that? So, 1 paired with 2, 2 paired with 5, no negative numbers, no. For example, minus 1 is there, minus 1 also paired with 2 only, but minus 1 won't be in the domain because domain is natural number. What is the meaning of that? If f map n to R defined by f of x equal to x square plus 1 is given, directly I can say it is a 1, 1 function. Okay, different elements of domain are paired with different elements of codomain. So, important thing, students, while verifying functions 1, 1 or not, when the functions are given a rule form, should take care. You need to consider the domain, codomain and rules. By using those only, you can check the answer. In previous example, R to R given, here N to R, I changed N to R. Domain is N, codomain is R. N to R given function is 1, 1. But how to prove? Proof important. Proof. Checking. Okay. Let x1 comma x2 belongs to domain. Automatically there exists f of x1 comma f of x2 belongs to codomain. Why? Means f is function. Since f is function, two elements are there in the domain, automatically what I am saying, their images should be exist. Why? Because f is function. Let f of x1 equal to f of x2. What is my assumption, Anna? Here x1 is given, x2 given. Automatically f of x1 image, f of x image. I am assuming that these two are same. What should get? These two should same. Okay. Yeah. Yeah, f of x1 is what? x1 square plus 1 equal to x2 square plus 1. Or x1 square equal to x2 square. Here I directly can say x1 equal to x2. What is the meaning of this? F of x1 equal to f of x2 implies x1 equal to x2. But the definition of 1, 1 given function is 1, 1 function. Therefore, f is 1, 1. But important, students, if here R is given, for example, here R is given, f map R to R is given. Same, you want to check whether f is 1, 1 or not. This step is same, this step is same, this step is same, here. This is becomes wrong step. Because, yeah, a square equal to b square given, we can't say that a equal to b. A may be plus or minus b. A may be minus b also. Okay, a is taken as 2, b is taken as minus 2, satisfies. So if a equal to 2, b equal to minus 2 satisfies means we can't say that a equal to minus 2 equal to minus 2, no. That's why if negative numbers are allowed for a and b, so if a square equal to b square, directly can't say that a equal to b. So what happened? R to R, no, here. So x1 square equal to x2 square. Most of the students will make mistakes, Nana. They will cancel these two. That's not correct knowledge of mathematics. Don't cancel none of those. Actually, we'll get mod x1 equal to mod x2. If these two are positive, directly x1 equal to x2. So here real number, no, they may be a positive or negative. That's why this doesn't implies that x1 equal to x2. That's why f is not 1 1. Okay, but rather than this, taking examples are better to prove the given function is not 1 1. Function we want to check whether function is not 1 1. Already by using observing the rule, you can conclude that function not 1 1. Better to take examples, Nana. So disproving by using counter example. Yeah, students, this class is very important. Yeah, 1 1 function definition I explained. Number of 1 1 functions. Okay, so after that, yeah, how to check a given rule is 1 1 or not. Okay, students, listen now. F map R to R given by f of x equal to x cube plus 1 by 3. Now you want to check whether this is f is 1 1 or not. Cube, no, should take care. Cube. Square 4 means it sometimes not become a 1 1, but cubes means no problem. So what I can say first, how to write steps later. x1 comma x2 belongs to domain. Then there exists f of x1 comma f of x2 belongs to codomain. Let f of x1 equal to f of x2. This is the procedure to prove that a given function is 1 1 or not. Okay, f of x1 equal to f of x2. F of x1 means f of x is, no. So what is that? x1 cube plus 1 by 3 equal to x2 cube plus 1 by 3. Students, multiplying through by 3, what will get? x1 cube plus 1 equal to x2 cube plus 1. Subtracting one another side, x1 cube equal to x2 cube. Square, this is not square. Directly I can say that x1 equal to x2. Okay, therefore, I will write, therefore, f of x1 equal to f of x2 implies x1 equal to x2. Therefore, f is a 1 1 function. For example, instead of r, okay, r only, for instead of 4 given, here 4, here 4, here 4, here 4, here 4, here 4. Here step is mod x1 equal to mod x2. Because x1 is taken as 2, x2 taken as 2, then all satisfies. So minus 2 power 4 16 only, 2 power 4 all 16. So from that you can't say that minus 2 equal to 2. Means that in this situation function need not become a 1 1. So if r is changed, r instead of r w given, automatically this also 1 1 function only. Okay, Nana? So this is important concept. Please revise all the concepts. Next part I will explain remaining types of functions.